So today I am delighted to have Dr. Jong Hyun Wu and Namju Lee. Jong Hyun Wu is at the bottom here on the screen for me. I'm not sure where she is located in yours, but she is the director at AXU platform. She's currently based in Cambridge, Massachusetts, up there, maybe getting a little bit colder now than New York. And she recently finished her doctorate degree at the Harvard Graduate School of Design, where she has been there as also a master's student. So maybe about, I believe, 6-7 years, conducting a lot of research that she'll be presenting today in relation to urban network and connectivity. I have a student joining here as well. So, and then we're also joined by Namju or NU Lee. He is the director or founder of NJ Studio that looks at computation and also architectural visualization. He is currently a computational designer or software engineer at Esri, and you guys are all using ArcGIS that's produced from Esri. So he is working there as a software engineer and has worked with me on numerous research projects. And his focus is in architectural design, visualization, and computational design. And both of them are working on this Grasshopper plugin that's called Numerical Network Analysis that helps us to understand the connectivity in urban design. So they're gonna give us about an hour presentation, then we can have a discussion. And I've asked them to maybe focus on not only how it can be used, but how the principles of the program can help us understand better the urban connectivity and how people actually use and get to interact with urban environments. So with that, I will hand it over to Dr. Jong Hyun Wu and Namju Lee. Thank you very much for joining us in the morning.
Yeah, thank you for having us here and the introduction. Jong Hyun and me, we have been developing a sort of system to analyzing network urban condition. And one of the outcome is the program that I'm going to introduce with her. So this sort of presentation consists of two parts. One part, I'm going to quickly describe a technical aspect of the network analysis. And after me, the Jong Hyun Wu going to introduce and describe how we implement and interpret the result out of this analysis, which is allow us to analyzing your site. Okay. So I'm going to share one of the link that we had a sort of workshop. So we record all the workshop as a sort of video, and then we upload them on the YouTube so you guys can find it. So the reason I'm point out this workshop is because we have a limited time today. So all the important and detailed information on this list, so you guys can find some video and yeah, and tutorial things. And also we have a two part, as I said, like an urban network analysis that Jong Hyun Wu going to describe later after me. And then also I'm going to quickly talk about the technical aspect of the network analysis as a CS perspective, for example. So there's a material, but if we go to this discrete space and connectivity link here, that it shows us this website. So I'm not going to talk about this one deeply because we have limited time. So there's a material. So basically, in order to use the network analysis, we need to understand the graph theory. So graph is not just like something complex mathematical object, but also it is very useful to describe the real world in a certain level of abstraction. So we use not only a graph for describing the social network or transportation, but also we can use the graph system for associated geometry and interface and network, and even for the mesh graph. So there's some examples. So if you guys are interested in, I encourage you to drop by this Medium page that I will leave the link in the chatting after Jong Hyun. So there's also some examples of how we use the graph for your design and research. Okay. So this is the all the English version of the workshop material. It has something to do with the NNA tool that we are going to use today. And then the last material before I start, we have a link in Food for Rhino. So you can search NNA, which is numeric network analysis. And then you guys can download the plugin from here. Once you download it, you can unzip this zip file here. It consists of two folders. One is add-on, the other one is an example. So in the add-on, we need to copy these two files into a special folder. So for example, if you want to open the Grasshopper here and click the file. Okay. There's a special folder, component folder. If you click the component folder, it opens a library folder. So in this folder, there's a weird yellow rectangle. Anyhow, you guys can see my screen correctly?
We just see a gray box.
Folder, right?
Yeah,
because I saw yellow, orange rectangle windows that capture only my one window. Anyhow, so we can copy this file in the add-on folder to the library folder here. Yeah, and then restart Grasshopper and Rhino, and then you can see this NNA V2 plugin add-on in your Grasshopper environment. So now you guys can see my screen, the Rhino and Grasshopper window, right? Is that correct?
Yes.
Okay. Great. So this is very brief history and some material that you guys can take advantage of it, and download the add-on and how to install the add-on to your Grasshopper environment. Okay. So the add-on consists of 3 parts. One part is the, let's say, for the geometry, because in order to create the network, we need to draw network, right? So without the network, we couldn't analyze, right? So this, it has something to do with the, let's say, network builder, yeah. And then this is the key analysis, yeah, that Jong Hyun Wu is going to describe quickly and deeply. And then this data section has some visualization tool or some linear regression and data description things. This is basically helper, yeah, for your result or analysis. Okay, so I draw 3 simple sort of Rhino geometry. So for example, the first one is I draw the polyline, right? So you guys are familiar with the Rhino, right? Yeah. So see the difference between polyline and line, right? Okay. So yeah, line is just one entity. It has a start and end points, right? And polyline has multiple points that connect, right? So, but for the network analysis, the polyline is not suitable. So we need to decompose it. So for example, you need to select them and then explore and then we reconnect line by line if they have any intersection, right? This is very, the labor-intensive work. So we have the plugin, the component called split polyline to line. So I select these polyline and lines, and then connect this to geometry component.
Hey, sorry, Namjo. I think you are just sharing. Are you intending to show something at the moment?
Yeah.
We're just seeing the browser. We're not seeing your Rhino.
Okay.
Screen.
Let me environment. Yeah. So okay. Yeah. This is the, as I said, this is polyline and line. I'm select these points and then connect this to geometry component. And then here is one tip. If you press Ctrl and Alt on the keyboard shortcut and then click the left button on your mouse on top of any sort of the component in Grasshopper, it gives us like the path where you can find. Okay, so here, here is the component that I use, split polyline to lines, right? So we simply hook the information to that component. The output is going to be, the line is basically decomposed line by line if there has any intersections. So here we have index. As you can see, all the line is decomposed, right? So this is the sort of perfect condition to create our network for analyzing the context, okay? And not only that, but also, what if we have this kind of network, right? And we have a special component to, let's say, increase the resolution, yeah? So in this case, the 4 is the unit, the linear unit. So based on the 4, we can divide the line if the line is longer than the resolution, just like that. So for example, I'm going to decompose my network, like let's say 2 meter, for example, or 2 kilometer or 2 mile. So based on your unit system of your project, but we have a sort of option so that we are able to create a more high resolution network. But actually, I'm not that recommend use this component in the first place, but just use just build your network from this sort of clear the line, and then if the performance is good, or if you wanted to really zoom in a particular area in the network, then you can copy this particular area, and then you can increase the resolution of the line. So this is sort of a tool, yeah. And also we have actually there are 5 points here, as you can see, meaning that the 3 points is duplicated in one place. So in this case, we have also the other component right here called let me click remove duplicated points. So the input point is 5, and then output point is going to be 3 because it basically removed the duplicated point. The reason I'm introduced this component is because once we have a network, and the most important thing that is we need to declare the origin point and destination. When you set up the origin point and destination, sometimes people use like a duplicated point, which actually give us a little bit weird or wrong result. So this is basically sort of helper, to create, to create our network. And then these are one of the examples that Jong Hyun Wu is going to describe deeply and quickly. But let me describe this example as a technical point of view. Okay. So we have a load here. We have a load here. Yeah. And then we can decompose the line. And this is the special component to create the network. So if you change the true, then it's going to be calculated. And we have the street graph here is become origins, and this for the park square in Manhattan has become destination, and this is that's it. I mean, this is all you need to do to create the network. That's it. And then we have the basic analysis. So simply like a hook it and then just inspect the data. So it not only visualizing the information as a color or any other like sort of visual language, but also it gives us a number. Number is really important to interpret. Yeah. So these are all about the example. It's a very clear and repetitive process. And then really quickly, we have the data tool. So as I said, once we create the network analysis and the network system, and we want to analyze, and then the most important thing is to interpret and understand the number, right? So in order to understand or interpret this result, we have a multiple sort of helper. So one is the bin system. I don't know how many of you guys are familiar with the bin. Bin is basically like a tessellate the information. So for example, like we have a random 100 information, values between 0 and 1. And then we can have a, let's say, 4 partition between the minimum and maximum number. And then we can pull it so that we are able to see how many numbers, I mean, the data itself is in between the particular resolution. So for example, if we put the number 3, the 35 means like 0s to 0.33. And then this 32 information indicating the number of the data which located inside of 0.3 and 0.6 and so on. Yeah. And also, I'm not going to talk about the decay and gravity because it's going to be little duplicated content with Jong Hyun. And also, we have some sort of scatter plot things. Okay, like this. Yeah. So we have some special function to generate the data here. And then we have some scatter plot here. And then this is special component to report a summary of the data, like how many data we have and what is minimum and maximum, mean, and standard deviation and things like that. And the last thing is we have a simple linear regression. So the purpose of this linear regression is that once we get some information or data out of network analysis, we can find some trend line throughout this component. So here, as you can see, this is the data, right? Data point, and then trying to find the fitting the trend line among this data. So this is the other example. If you have interested in, open it and try it. Yeah. So I think I'm done on my part. So I'm going to leave this window to Jong Hyun.
So great, thank you very much. If you have any questions, if you can just note it down just for now, and then we can have the questions addressed after the whole presentation. So thank you very much.
Thank you.
Yeah, I will explain introduce the concept of the tool and the interface as well. So, but my presentation will be focused on the network analysis as a field of urban planning and design field. So, yeah, I will begin. Yeah, can you see my screen, my browser? So,
yes.
Yeah. Here is the introduction page for the numeric network analysis V2, which the NJ just to show you the through the Food for Rhino website. So if you want to get a more detailed idea in terms of NNA V2 toolbox for basic you can find this web page and then you can read it. I will just very quickly explain all the introductions and interface overview for the tool. So, so numeric network analysis offer kind of like easy approaches for measuring distance and analyzing various accessibility and centrality concepts. So as you can see our interface, when you open the install and open the NNA V2 toolbox, there is a two concepts, like one is centrality and the other one is accessibility concept. So actually many people just mixed up, like they don't really clearly define the concept between accessibility and centrality. But in a graph theory, the two things are very different kind of concepts. So I will explain very quickly for each concept and how they are different. And so this is network analysis, right? So you're gonna understand about the distance issue in a special network and location issue and travel cost and time issue, of course, right? So actually this tool is available. You can calculate all these kind of urban factors. Even though we call it very basic kind of toolbox, but still it open very kind of very basic but very fundamentally important kind of network analysis. So you can do through this add-on application. So the benefit of this is, so while you are doing like design progress and or when you need a decision making to evaluate the quality of your design or planning, actually this tool is help you out, to make clear decision. For example, my building location is how important in a city, in terms of location wise, how centrally located in a city or in a town, or what is the travel cost, from station to your building, or what is the travel cost from your CBD and to your building, for example. Or if you design the big shopping mall, the circulation plan is very important, right? So once you complete your interior design or layout of the spatial layout, you can also evaluate how each spaces are more important than the other or something like that. So as you can see here, you can evaluate designated network, which I can say like you design the circulation plan for the architecture building, you can evaluate it. Also, once you evaluate it, you can also redesign the path and you redesign the circulation, and then you also re-evaluate as well. And as I said, the new building location impact in the cities also you can understand through this add-on application. So as Namjo said, like we have 3 parts. It's very simple actually. We have 3 parts, means that if you just plug in like 3 components, you will get the network analysis result or outcome, for your site or for your architecture building. So first one is about to clean and to assign the network, to build the network for your analysis, basically. And second set of tool is all about the analysis. As I explained, there's a 2 key concept, while you are doing the network analysis. The first one is this one, D3, gravity, half, and reach analysis. We can call it accessibility analysis. And the betweenness, closeness degree, and straightness analysis, we can call it centrality analysis. So there are 2 different key concepts, and we always need this network analysis components. This one collect all the network and road or like all the lines, and then just link to this one of those components, and then you can evaluate the graph. So this is for the visualization purpose. This is helpful out to interpret or like visualize your the network result. So as I explained, for the theory part, like there's two things, right? The accessibility analysis and centrality analysis here. So accessibility analysis is kind of like accumulative like opportunities, you know, at a location. For example, if you stand here, like here is the examples. The destination is MBTA, like 3 locations here. I just draw a pen. So here is a destination, 3 destinations, and the origins are housings. No, so which means the end the network is the road, right? So this one means that how people travel from their housing to MBTA, like subway stations. So this one shows that how this MBTA can capture how many housings around the station area. So in this case, the setup like 600 meters walking shed. So it means that how many each subway stations can capture number of housing within 600-meter radius. So the reach analysis is simply calculate like the accumulative, the opportunities of origins, right? And then the gravity analysis is like the basic concept, fundamental concept is same, exactly same as reach, but the difference is considering the general cost, the travel cost, for example, or travel condition based on the reach analysis. So for example, if the weather is bad, of course, people are not willing to walk, you know, than sunny day or pleasant weather. Or for example, in Manhattan, people are likely walking in a city, but like other like suburb areas, people don't like to walk, you know, on the street. So this kind of like urban context or weather environments can impact on the travel cost and travel time and travel distance, right? So this gravity kind of considering all these kind of environmental like the factors. So discount it eventually discount the total number of capturing area like from the reach outcome. So the result of gravity index always lower than the reach. And this Hoff model is very useful to understand the probability as a percentage of travelers. Like, for example, here is the origin, and I have 3 options to as my destinations. So this one calculate your probability. For example, like how much chances you will get here, you will choose here, or how much chances you will choose this destination, and how much opportunities you will get these locations. Because the 3 locations are like MBTA station, right? So if you stand here and if you have 3 options, like which location is better for you? And the second one is the centrality analysis. centrality analysis is about the hierarchy of the node within the network. So if you can interpret the number and color information on here, actually always the warmer color represent the higher value than cold color. So the blue color means lower value than the warmer color like yellow or orange or red, right? So that's a kind of very basic rule, you know, the many urban planners and designers understand, or when they are doing kind of very technical mapping on a map, this is a kind of common rule between us. So the centrality, through the centrality analysis, you can understand which node is more important than others. So there is a 4 key concepts in a centrality analysis. The first one is betweenness. The betweenness analysis can reflect the realistic pedestrian flows in a network. So for example, the red color means that higher pedestrian flows density than other places. So, and closeness concept represent how close an origin is to all other destinations. So here is also, I defined the 3 MBTA stations are the destinations, and all the points are housing location. So this is makes sense, right? The centrally located houses are more better or better closeness index than the outskirt housings, right? And straightness means that the efficiency of network connectivity. So if the network physical context between origin and destination, if the network context is more straight line than like more curvature shape, the straight connectivity between origins and destinations has better straightness, because it's more like efficient kind of travel, right? Because it's just simply link between origin and destinations with a straight line. It means that the most efficient travel route, right? Rather than detoured or like more curvature network shape between origins and destination. And the degree part is about the simply count of the total number of connecting edge for each node or for each edge. So I will show you how we use it for the urban design or site planning analysis by using example files. So those are the basic concepts for NNA V2 toolbox. And yeah, if you have any questions, just send the email to us and we will reply and answer to your questions. So I'm going to share this page after this lecture, and I will move into the example files. So can you see my Rhino and Grasshopper screen?
Yes, we can see it. Thank you.
Yes. Yep.
Good. So as I explained, we have 2 concepts, like the 2 big concepts. First one is centrality and second one is accessibility, right? So we develop, once you download our Azure file with example files, you will find 3, in basic folder, there will be 3 example files. So first one is a centrality test example, and second one is a accessibility test example, and third one is about more architectural scale, like interior scale, circulation, kind of evaluation test example files. So I will explain one by one. So once you download it, you can also play and test with your work or study again. You can study again with our example file. So the site is Manhattan. It's very familiar to you guys, I believe. Here is the Midtown Manhattan area. And then the origin is the street cafe. The street cafe culture is very popular in Manhattan, right? And the destination is Four Squares, which is from Union Square to Times Square, the Four Squares. So the question is like how between. So as we explained, like we have three parts, right? So this one kind of clean up and rebuild network, for example, this road context for our network analysis. So in here, if we have this network analysis component and one of this component and one of these data visualization component, actually you can get your results. It's very simple, I think. So this is all about the bringing the data. So first we need the raw data, of course, right? Second one is origin, and we need a destination. And then we can start to build up the network analysis. And here is a network analysis component. And the first one is about the betweenness analysis. So in this component, as I explained on the web page, the betweenness analysis reflect the realistic pedestrian flows between origin and destination. So the NS to NS here, you just link with the result of the setting up network data to here. And offset means that you can define the width of the result, or size of result, let's say. And then PL is like showing up the outcome, which network are used, while you are doing for your outcome, for example. Like, for example, here and text, as you can see, and there is two different kind of text outcome. So first one is like index value. So index value is not an absolute value. It's more about like the value always between 0 to 1. So you can understand the relationship, like within the whole outcomes. But this value is like more absolute value. So for example, like this number just literally reflect the actual number of pedestrian foot flows, on this street. So for example, like 72 means that on this node, 72 people just pass by on this node. So yeah, you guys kind of can understand interpret the number, what is the meaning of the number, right? So if you just very quickly understand, okay, how many people just pass by here between origin and destination. The origin was the cafe, right? So for example, here means like if people start to travel from street cafe to Four Squares, like 42 number of people can pass by here. So this is a result, and here is you can do also linear regression using one of our data components. So in here, I just set up 8 kind of scenarios by using the land value as a weight. So this land value data, I just bring from Google. So it's very generic kind of idea of the land value data in Manhattan. So you call it, and so for example, like if the land value is 1,000 per feet, or the cafe is like this, and $800 and $600 and $300 like that. So here, what we want to examine is that the relationship between the pedestrian foot flow and the land value of each cafe. Because like, of course, maybe higher land value cafe could be more popular cafe, because if the owner should pay more rent to run their cafes, like they have to have more benefit than others, right? So more benefit means that more people can, more customers might visit the cafe, like that. You can build your own scenarios. You know, I had just like land value data at that time, but if you have like sales data, for example, it'll be more directly in impact on the pedestrian flows, right? So you can when you are doing the network analysis, you always have to think about what is your hypothesis or assumption. You know, like, okay, of course you can just simply compute or calculate the number of foot flows. That's okay. That's also very meaningful. But you can, based on this very basic analysis, you can develop further. You know, based on your research hypothesis or research scenarios. So by using this outcome, the foot flow, pedestrian flows data outcome, and then the relationship between the land value, and to see the simple linear regression, and okay. Yeah, before, if you really want to get the network analysis result, you have to always turn on this toggle key as a true. So here you can see there is like 77.4% correlation between the land value and then pedestrian flow results. So it's quite very high relationship between two. And then next is closeness analysis, which means that how the which origin has a more kind of close relationship with the destinations. It's kind of makes sense, right? If the cafe is more centrally located in this network, it has a better closeness index. So here the better closeness means that the lower value is more close to the destinations, because closeness means it's about the distance, right? So lower distance means better, right, than longer distance. But sometimes under certain kind of scenarios, you can also say maybe longer distance is better than shorter distance. But in general idea, you can say the close distance is better than longer distance. So color represent always the cold color means the lower value than the warmer color. So this one tells the correct information, and this is the loading is same. So you can check it later yourself by yourself. And then the degree analysis is about the number of edge connectivity. So here you can see if it has like 4 edges, it will represent like this orange color, but it has like 3 or 2 edges at a node, it has a like lower index value. Let's see here, right? Here is the 4, 3, 2. So what is so good for this concept? Like, of course, you can understand the physical context of the built environment, right? Which know there's a more connectivity with the neighborhood, right? If you have a better connectivity means like more connectivity with your neighborhood, it will show up like higher value, right? So you can very directly understand the physical context of your built environment. And the straightness analysis showing the straightness of the network, right? So okay. So between the origin and destinations. So if the network has a more kind of straight line between the origin and destinations, it has a better straightness value. So it means that it has a more efficient network context or condition while you are traveling between origin and destination. So in this example, to simply explain which connectivity is more efficient while you are traveling to the 4 squares. From this one is from cafe, and this one the origin is from cultural spaces. So from this bin component and this graph interface, actually this one looks more like a normal curve, and this one is more kind of randomly distributed kind of context. So you can, I just explain here more detailed kind of like interpretation for the each outcomes and results, so you can read it later. So you can also compare like which one is more kind of efficiently connect to A spaces, you know, if you have a different departure point. And next one is accessibility analysis. Actually, as I explained before, the reach analysis and gravity analysis, actually the logic behind it, fundamental kind of purpose is same, but the gravity analysis is just to discount the result out of the reach analysis. So reach analysis capture the here the how many origins can get to the destinations. So for example, here the origin is the 4 squares and destination is the street cafe. So here is origin and here is a street cafe is destination. Oh, yeah, sorry, I will explain again. So from origin, how many destinations you can access within this given radius. So here you can also define the radius, so travel distance from your origin location. So here I said the like 3,000 radius is your travel distance. So if you want to travel from 4 squares to street cafe, so how many street cafes you can access from here if you just walk 3,000. Here we use a mile, I think. Yeah, 3,000 meter. Sorry, he was like 3,000 meters. Like how many cafes you can access here? It's the same kind of context and environment, research environment, but let's see like how different the number. So in a rich analysis from these squares, you can access 10 street cafe, but once you discount with a 0.001 beta value, actually the results showing that actually you cannot, it's a 0.7 street cafe you can access. It means that actually you cannot reach any street cafe from this location, right? Also, this is you can control this beta value. Normally you use it like from 0.001 to 0.005. So if it is a higher value, means like more discount. So when you consider the weather condition, like for example, the weather is very bad, you can increase this beta value, right, to 0.003, something like that. And here we developed the component is that you can also export your outcome result as a CSV file, so Excel file. So you can use it as your kind of next step, kind of statistical analysis variables by using this network analysis algorithm. So the last one is a half analysis. Half analysis is about the like probability, right? So here is a network, and again the street cafe is origin, and people walk to for squares, and so what is the probability, you know? So here, and also you can here define your travel distance. So here I set the travel distance as like around the 4,700 meter, and here we always need a kind of like inspection point or one of the selected ID from origin. So these points can reflect one of the street cafe's location. So for example, this is point inspection. So from this street cafe, I have a chance to get to this for this square as a 0.09%, and here the 0.8%, and here is a 0.1 chance. So when I transform this 0.09 value into percentage, sorry for the confusion, like this is like almost 10%, this is 80%, and this is 10%. So I just want to correct my interpretation. So this is the 10%, this is almost 10%. Yeah, this is also 10%. This is like 80% if I interpreted this number as a percentage value. So if you are located here, you can you will visit these squares rather than these two. And if you move the points like here, the inspection points, you can also get a different probability, right? For your when you decide your destination location. So this half model is very popular to evaluate the retail like marketing analysis. So they understand like if customer located here, like which shops the customer will visit in the future, something like that. So this whole model is very popular, particularly for retail location analysis. So this is all about the example for our basic analysis tool components here. I explained all these 7 concepts. Not only for this urban context, also you can use for the like building context as well, building scale as well. So you can still use the same concept, but you can use it for your architecture scale. So I will just quickly show the results, and you can study later on by yourself. So for example, here, I just get the like second floors, the floor plan, and this network means like corridor, right? Or it can be the corridor, and with the between analysis, we can understand the actual pedestrian flow numbers or densities on within this second floor plan. And using also the reach analysis, you can also see which corridor is very more used than this network color represent the distance value from origin to destination, and this betweenness result showing the density of the users context. So for example, this like more red points area means like more kind of crowded corridor than this blue color node area. But here always the setup, the context is like the room, how people if people travel from room to exit here, so this kind of very quick, very fast-paced network analysis is very useful for your building circulation planning or evacuation planning. So if you just set up like exit or entrance location, and then you just quickly compute using these 2 components, and then you will get the result, right? So you re-evaluate your circulation or corridor design and location of rooms, and then you just re-evaluate it and can also redesign by your intent. So yeah, here is yeah, I will finish wrap up my presentation today. If you have any questions, yeah, I'm happy to get your any questions for our presentation today. Thank you.
Great. So thank you very much again for both of you presenting not just something that's super useful for us, but something that you are working on, and sharing something that is very live. I think it's really exciting to see something that is being developed. So I have many questions, and I think if we just go back to the last example, I think, yes, this analysis tool, we were trying to introduce you as a way to understand some of the connectivities that we have in urban conditions. But as mentioned by Jong Hyun, it's also obvious that it can be used at multiple scales, which we talked about, in environmental design or urban design. We need to think about different scales, and to be able to understand this building scale, I think is also quite important. And I was just looking at the images that were shown as examples, and those red hot spots in the building could correlate to places where, if in these situations that we're in, those are the places where you might actually get the virus called COVID, or those are the places that needs to be cleaned more often. So, you know, these kind of things that talk about the density of circulation, I think some of them are very obvious. If you look at the plan, you know, look at the actual layout, you can kind of get a gut feeling of where would be the most used place. But what's really useful and very effective for using this tool is that it's not only giving you actual numbers that you can objectively kind of compare, but also it gives you something that allows us to see it in a visual form. And the real advantage of this is that you are able to use the plugin to shift those values in a very comparatively easy way, where you are able to use it as evaluation tool and feedback tool to refine your planning or design. So in that respect, I think the last example was quite effective for me in particular to understand that agency of this tool. I have a couple of other comments and questions, but before I do, I would like to open it to the students, especially now students are just picking up Rhino in this semester, and they are starting to be introduced to Grasshopper about a week ago, I believe. So they had a first session with some introduction to Grasshopper. So this is maybe their second time looking at some plugin that does something at urban scale and at this kind of juncture in this semester. I thought it would be very effective to introduce this concept to the students, where you start to understand environments through computational thinking, which I believe is becoming more and more important as we go into the future. So students, do you have any questions or areas that you would like to have some clarification? I know this is a lot of information, and if we let Namju and Jong Hyun talk about their work, we can be here all day because it's a rich material that they have. But they just really went over the glossed over the tool that they have, and obviously you can go into their website and see more, look for more information. But I would like to hear a little bit from you guys. Yes, Abdullah.
Okay, thank you. Well, first of all, thank you for the presentation. It's really opened our eyes to this new program to us. Well, I just have, I'm curious because this, as you showed us, this plugin and this program has many unique advantages. So we can get transform it. For example, you talk about we can know the density and how the truffle paths from Cafe Street to the squares. So my question is, can we apply this this plugin to, like, for example, if we can know the option, like if we want to reduce, in the architecture scale, if we want to reduce, I'm thinking the, for example, the marble in the corridor. So can we calculate it, how much money we'll save if you use how many options do we have to reduce, for example, the marble and the corridor and the floors? And my second question is, how far is this program? I just, something came to my mind. For example, can we use it outside of the architecture and urban and built environment? Like, for example, when I saw the lines in Manhattan, something came to my mind. Like, I'm interested in aviation, so can we apply this with, if we think about airplane paths, like if airplane travel from city to city, like we have many options we can see it from this program. Like we want the plane to I mean cross by city A and city B, then city C. I mean, I know it's the question is really outside of the
Oh, it's very good question. Yeah,
that's
very good question.
yeah, that's thank you.
Yeah. Yeah, actually it's available like if you have like three things, you know, if you have your network line, and if you can set up your destination and origin, actually you can evaluate anything, you know. It's really across the matter of scale, you know, even though it is interior or still this one is a still architecture scale, but if you just zoom in and if you just design for this room and you know like you can draw your network like circulation in a room, and then you can also evaluate, you know, like. And also I use with this tool to evaluate the subway network systems. So it's a much larger scale than this Manhattan context, right? Which I show you today. So yeah, it's still available. I didn't try with the very regional scale, you know, like across the cities and airplane network. I didn't try it, but I I think it's available, you know, like you have a like airport location and you have a like air flight kind of like traveling route, and you can test it. And it's also available as a like not only like two-dimensional kind of plane context, is also available with like three-dimensional kind of context as well. I didn't show you guys today, but this example is about like I just yeah made myself. This is like fifth floor kind of floor plan, and also you can test it with like this three-dimensional kind of context as well. So yeah, I think like the you have an air flight route and the airport location, and you can also test it. It's really across the like the matter of scale.
Yeah, also I can give you one sort of perspective. So basically the network, in the network analysis that we deploy in this plugin, we use sort of the shortest path, let's say Dijkstra algorithm to get the shortest path. So just as I said, the computational way, there's two different types of approach. One is the deterministic way, the other one is a very stochastic way. The deterministic way is more about like calculating and get the result. Every time you can calculate, the result is gonna be same because this is deterministic things, right? So we have this kind of network on the screen. So this is my starting point. This is my destination. Every time you calculate, the result gonna be absolutely same, right? And however, in the stochastic way, is based on the parameter or some way, the path gonna be a little bit different. So when you try to calculate the airplane path, for example, based on the shortest path, then I think we can apply this algorithm because we use the shortest path as a cost function to determine which path is going to be take as a next step. And also, when I heard your questions, I recommend you search like traveling salesman problem, which is a very famous question. So, for example, we have multiple customers, and then which path is the more optimal in the solution. So, I mean, this is very common and famous solution. I recommend you search it. There's a lot of history behind the scene. But the network sort of cost function that we deploy in our network system is more about like finding shortest path. So if you have wanted to apply the path for the path for the airplane based on the shortest path, then you can also directly use our network as well. And also, as Jong Hyun mentioned, we have 7 different types of the concept, right? If you apply the 7 concept to revealing some new solvable path, then also we can apply our individual analyze plugin for the calculating. Actually, it's more about like how you create your hypothesis, right? I think this is very important. Also, based on the hypothesis, we know like which, I mean, as I said, like a destination and origin is really important. So then based on your scenario or hypothesis, we can have some clear concept to revealing some data based on the different types of the origin point and destinations. Yeah.
Thank you. Thank you.
That's a great question, and I think it expands our sort of discussion into computational design, and I think that's where a lot of what we are being trained to can be applied to something other than just designing a building and architecture. So Ritik, you had a question?
Firstly, thank you for this presentation. I mean, the other day when we had another Grasshopper session with in a design studio, I mean, it was a similar Grasshopper program where it showed, I mean, different hypotheses of sites which can be learned from your different parameters. So, can we? I mean, it's a question that can we follow the same path of program, but the other way around? I mean, here we are getting different points and distances. What if we give the parameters? We want the distances to be this particular distances, this close we want the site to be. Can the same flowchart can be used to find out the best possible sites which is closer to this point or closer to this point? This can be helpful when we are trying to choose a site in a complex layout or in a complex city neighborhood or anywhere. I mean, for in a client point of view, I want to choose a best site where I can have more number of people coming over, where I can reach out to more number of people. So can we do that other way around, giving the parameters and getting the possible site? That is one thing. And the second thing is the thing which came to my mind was uh, finding the best fire escape routes and fire escape locations. When I was working in my previous office, I had to calculate each and every point by pointing out polylines to nearest fire exit routes. So this can be automated by following the flowchart where I mean the program gives you best possible locations and shortest path of fire escapes in the particular layout. So I think these are the two things I want to ask you.
Yeah, I can start answering your question. So first of all, I have no idea what kind of program did you use previously, but I mean the individual plugin, particularly dealing with the network, they have their own sort of goal, right? So the network analysis, as I said, very deterministic. So everyone can like measure individual line and then sum them the distance and then pick the shortest path. But however, during the calculating, we can actually apply some particular, let's say, parameter weight, for example, like a height, weight, attractiveness, or deviation things, so that we can create our sort of, as I said, like the sarcastic calculating network, I guess. So, but let's say our plugin is more about revealing and calculating the 7 the parameters like a centrality and accessibility that Jong Hyun analysis, Jong Hyun explained. So if you, I mean, if you wanted to select a particular site in your urban environment, and as I said, the individual tool has their own sort of target, right? So particularly our tool is not suggesting this site is better for you, but it gives us like sort of a lens or a perspective as a 7 different parameters. So you guys can decide based on your hypothesis. So for example, if you wanted to build like a shopping mall in that site or housing, they are different, essentially different, right? So in this case, you guys can make some sort of hypothesis or criteria to pick your site based on the 7 different regions. So let's say this is sort of the material, yeah, for your cooking, yeah. So I think this is a better sort of approach to take advantage of this tool. So as I said, as an architect, set up the rule and then deploy this kind of plugin to get the result and then compare them, right? And then to answer your question, the second question is more about like the evacuation plan, right? So as I said, the network analysis, we use shortest path as a cost function. So the other day, last year, actually, one of my friends asked me to create some of like the network analysis for the evacuation plan. Like for example, fire, happening first, and then after fire we have some smoke, right? Actually, the smoke is more dangerous than fire, and this fire is actually going up throughout the flow. So it has a sequences, right? So we can. For example, your starting point is some let's say 10th floor, for example, and the exit is obviously ground floor, right? So while you're trying to evacuate from this building, and then the flow is keep going, and then the flow, the smoke is also a little ahead of the fire, right? So you can set up this kind of rule, and then it has a time sequences, right? And then we can predict which one going to have a more smoke or fire. Yeah, so we can apply more high weight so that the path is gonna be try to detour this path. So I think this is all about like how you set up your simulating, how you set up your simulation. Yeah, it's about like the hypothesis, how we create the sort of rule, and then I think our tool is not specialized like creating the path for the evacuation plan, as I said, but I'm trying to decompose, yeah, and then how we set up the rule, and then what kind of cost function that we need to use, right? So in that context, we have also prepared the version 3, so which contain the weight, like deviation. So basically, the node can attract or expose the path. So using this concept, you can also use it. Yeah. This is my answer to your questions. Thank you.
And I think you can still use it, like using the basic tool, and you can evaluate which location is better than the other, because of course, like I think the different application has a different purpose and different kind of goal, like while you are using it. So in our tool, like particularly for this basic kind of version, we focus on all about the distance issue, right? By distance, when we think about the travel cost and travel time, we transform all this data into a distance, right? If distance is farther than the other, it means that it will require more cost than the other, right? So if you really want to evaluate, or like if you really want to compare which location is better than the other, you can, based on this distance issue, you can also reinterpret, which one is better than the other. So also this reach analysis, we just show, like, for example, like from this location, if you have a like under your kind of hypothesis or ideas, if you have 4 options, if you when you define your kind of design location or something, so among 4 locations, which one is better than the other? You know, like this rich analysis can tell you something, right? Because actually this location is very positive, right? It has more benefit than the other. If we say, if we wanna, I don't know, make kind of very crowded place, you know, if you need, for example, if you need more customer than the other location, this location can capture more spaces or more building locations than this location, right? Just by distance. So our tool is very good to understand the travel cost and travel time by using distance information. So this is a basic V2 version. It's a beta version, but the V3 or next version, we also imply the weight issue. So actually with the weight, we can do more things, you know, like you can set up more kind of sophisticated the scenarios and hypotheses for your design kind of evaluation or site planning analysis. So yeah.
Also,
So
yeah.
and another question is also using this half analysis. The benefit of this half analysis is like you can understand the probability, you know, if you have 4 options, and then if you stand here, you know, like you have 4 kind of choices, right? So which one is better than the other? You know, you can also kind of making decision, you know, while you are doing kind of progress. So you, throughout all these examples, you can reinterpret for your research question or research idea. I just create this example as simple as possible, because just try to focus on deliver the very fundamental kind of concept, you know, to you guys. So based on these examples, try to develop or kind of redesign for your research questions. That's what I recommended.
Yeah. Also, additionally, I think as a computation designers, there's lots of different types of network analysis tools, but I can use. But the beauty of our tool is basically 7 concepts. The 7 concepts is not like something special, but I have no idea. But Jong Hyun could answer better than me. But the 7 concept is a very when the urban design can comes up to the, you know, the how can I say, to become the area or domain, so a lot of people took their like research and try and error, and then they have been set up this kind of 7 lens of the urban network system. So I think my understanding of the 7 concept is more about like revealing the existing context, right? So that we can, as you asked me, it give us you know, the insight or number to differentiate or narrative a particular position in an urban system, which is good. Not only that, but also, for example, in this case, the Manhattan, the square, it has a 0 probability, right? Time scale, right? Is that correct, Jong Hyun? The 0 one? Mm-hmm. So time scale is revealing, oh, this is a 0%, right? But unfortunately, this is your site, right? So maybe in this case, the questions become like how we improve that site as a lens of the Hope model system. Well, what if we apply the rich or betweenness analysis? First of all, it's revealing the facts, right? It's revealing the context as a numeric number or numeric information. And then we can not only just use directly the number, but also we can try to improve or like the converge or diverge between the combination of the 7 analysis. Yeah, so I think it's more about like how you create the sequences of hypothesis or design idea. So I think the first one is Jong Hyun mentioned, just expose to the tool first, and then based on the 7 concept, and then you guys can try to rebuilding the existing site, and then apply you guys some sort of the design, the urban concept to your site, and then you can keep evaluating which fact can increase or decrease this particular analysis among the 7 concepts, things like that. So I think the 7 concepts is pretty important because, as I said, the revealing information is it's not that hard because just connecting components, that's it. But the most important thing is to understand and interpret the number. Yeah, that Jong Hyun wanted to emphasize and has a lecture today. So
just one point I didn't explain you while I showing this hope analysis example. Actually, we are actually keep developing to include this weight issue for each concept, but this hope model is already partially you can test with the weight with the different weight value. So for example, like if the weight value changes, like of course the very big, if the weight value is all same, like all 0, or maybe just one.
Yeah, 1.
Yeah, just 1.
0 actually make it 0 everything. So the default is actually 1 for all the weight.
So yeah, so the if 4 locations has all same kind of weight context, of course what you can imagine, like, you know, this probability is just calculated by the distance, right? Just purely distance. If longer distance, it means like less probability. You understand? Because longer distance means like more travel cost. So it will have lower probability if you make travel from this location. But like the first one is a union square, like this is now here is only around like 10%. But if I just increase the weight here, what you can see here, the probability just increased up to like almost 97%, right? So in this hope analysis, you can test with this destination weight, you can play with it. So not only just like distance issue, you can also include the weight value, and then you can test with this tool.
Then in this question is in this context, the question is how you create the equation to generate sort of weight for individual scales. So maybe you guys can consider like the physical environment or some, you know, the weather or whatever. So maybe it's just this is sort of like reverse engineer to, you know, create the sort of the weight for individual scales. I mean, there's a lot of things you guys can intervene. Yeah, the design process. Yeah.
Great, thank you. I just have maybe 2 questions. One is the example that you created of the center of Manhattan, Times Square. The students, if they wanted to start, I mean, I guess there are questions about where do you get data and the base map, but I guess they have access to GIS shapefiles, which they can use to the streets that they have, or they can also use OpenStreetMap to generate these lines and start to build up their network. But if they were to use, I mean, if you were to use Manhattan as a site, and if you were doing it from, I know you have some data that you have accumulated over years. But if you were to start as a student without having that access, what would be the best step to take to generate those basic network that you can start to apply this plugin?
Yeah, I can go first. So I mean, as I demonstrate in the first place, so in order to generate a network, we need the correct information, which is line. It's not like a polyline or duplicated like line, whatever things. So that's why we prepare some of a tool set here. This one, right? But I mean, even if we prepare this kind of helper for filtering the line and points, there's still the network condition is really important. So for example, if you download the like street or road out of OpenStreet or GIS tool, still we need to clean up. Otherwise, the network is not working correctly. So I guess
which one would you go first?
I would like to start like, I don't know, OpenStreetMap because this is easy. Okay. And then otherwise we can draw. Yeah, I think the draw.
I don't think it's good to start with OpenStreetMap because like
it's dirty, right?
I trust actually all the data from like kind of official kind of the government or like city kind of planning department always provide. Of course, if the site is in China, they don't provide all the data, right? So we have to draw by hand, or like you have the tracing on the Google Earth map or like whatever. Well, like I think in general, like particularly in United States or Seoul, like particularly like big cities, like since many kind of scientists and researchers talking about like big data issues for city environments, like it's relatively now it's very easy to get a kind of data from while we are access to the like government or city like urban planning department website. So first try to find the most reliable data or reliable kind of organizers, while you are collecting data, because you just collect like capturing all the data from somewhere here and somewhere there, and so you in the end you will get data, you will get data, but you cannot say like which one is more reliable than the other and which one is more efficient than the other. So yeah. I think the most important thing is that you have to find the reliable data. For me, that's most important. Yeah. Otherwise, if the data is wrong, like there's no meaning, right? So, but Manhattan case is like very easy to access many data. And when I develop these examples, I just visit the official website and then just download the shapefile. Luckily, the network file was very clean. I don't need to kind of rebuild or anything. So I think the New York case is pretty kind of good environment, which is about like data collecting.
Yeah, and then additionally, even if your load or CAD data looks clean, but if you zoom in a lot, then the loads sometimes they're not connect each other. They're like close enough, but in the certain zoom level, they looks like overlapping, but they are not sharing the points. So in this case, it become problem. So because in order to generate a network, at least the point need to be need to be to share the same location. Otherwise, they create some like intersection. But if the point is not meet each other, it become actually problem. So if you personally, when I build the network, download the reliable data and then create the network analysis and then test some basic like shortest path or whatever things, that it actually leave you a link. If there's the disconnect network, then we can extend the line, to make some intersection between them. So, I mean, the most important thing is that they need to meet. Yeah, then you guys good to go. Otherwise, maybe high resolution become problem, because sometimes in the GIS file or other open data, there's a one line. But between the line, there's an unnecessary point populating the inside of the one simple straight line. So it also become like burden to when you compute the path. So I mean, these are sort of a generic sort of a rule for any other network analysis, I guess.
Yeah, I think these are just sometimes technical issues, but they become quite difficult to deal with, especially for students who are starting out.
Right.
I just wanted to hear some, thoughts from the experts. I just had one other question, and you were, in this shared screen that you have, you were just kind of manipulating a few things just to show us some things, and moving the sliders to show how it kind of gives us instant feedback. And at the moment, I guess, I mean, we can do in a way anything with the computational sort of thinking, but with the plugin that we have, I was wondering if you had multiple sets of, let's say, data that might be of, let's say, in the morning, midday, or whatever, moments in time, whether it's a daily cycle, weekly cycle, and you would be able to, in some way, organically or fluidly plug them in, and then have them, just, I mean, we can always do that in a post-production sense with multiple images produced of those moments. But what do you think, would it be possible, or would it be useful to embed that kind of notion of time with multiple data or variations of data changing over time to be embedded in what you are making here at the moment? I'm sure you must have thought about it, but if I, in a very basic sense, if I were to show someone the change of accessibility or certain, connectivity over time from Monday to Sunday, and I want to show it in a 5-second animation.
So
what would you do with this at the moment?
Okay, so as a developer, I guess there is always dilemma, right? So if I create a like one shot component that take the data which contain the months or year, it's like I just hide them all the complexity behind the scene, and then I open this input and output. Then in this context, it's really harder to customize. It's really harder to use. Just think about the SketchUp. SketchUp is very easy and straightforward. But once you're familiar with, then you have a lot of problem or question. What if we have these features? Just look at the Rhino, because the Rhino has a pretty complicated program compared to the SketchUp, right? And however, if you have if you have material, then you can cook whatever you want, right? So, I mean, technically it's possible for sure. So if I were you, to answer your question, I create a Python component that consume the data, and then I can decompose the data day by day, or week by week, or year by year. And then I create the sum of slide or whatever, and then it generating the network, yeah, and then you create the result based on the data that I inject daily base or weekly base, and then we can save this data as a as an image or some CSV file. This is actually possible within this component. This is how you want to optimize and how you create your own scenario. But I'm hesitating. Sorry, encapsulating all the complexity in one component. I think it's okay for a particular problem, but it's really hard to make it generic component. This is sort of a dilemma for developer, I guess. So yeah, thank you for asking the question. But we are still trying to, create some like a convenient component that react to multiple generic situation. So yeah, definitely we consider like this kind of feedback. Then we can think about how we.
I think like as it is, we can do kind of some kind of simple test, by using, if you really understand, like of course, like just NJ explained to you, of course, like it'll be the new kind of the developed component can be more kind of effectively or like easy to test with the idea, but as it is, it's also possible at some kind of level if it doesn't need to be very kind of complicated kind of scenarios, because we are talking about like all these kind of like pedestrian flows, in a city, for example, this Manhattan example cases. So if you have a kind of, if we really want to look at kind of station areas case, right? Station area is really reflect the different kind of pedestrian flows by different peak hours, like morning or evening peak hours is the more crowded than during the day, right? Because like people go to work or back home, like, so always the morning and evening peak hour is more crowded than during the day. So if you have like 24 hours like ridership data, it already reflect the pedestrian flows around the subway station area, because people will get off and get in the subway station. So it generally kind of naturally populated, like the people flows, around the station area. So if you have this kind of betweenness analysis result by using our network analysis toolbox, and then you have this ridership data with 24 hours data, and then you can just do the linear regression analysis, and then you will see the kind of understand the pattern of how this number of ridership or like this fluctuation is related with this outcome of betweenness analysis. Our betweenness analysis is just very it's very good to understand the general built environment context, right? So like just by using the distance and also by using the location of the built environment, you can understand how people move around a certain location. So so if we really want to see how this time series context reflect or react with our this 7 different concepts, this kind of way of research I can recommend at this moment. But in the later, of course, we can add up more complexity based on our basic, this foundation concept, and we can keep developing. But at this moment, as it is, if you use our add-on application, this kind of research direction could be also available if you want to see how time changes related with this accessibility or network analysis.
And also the other way around of looking at the things is this is actually this is the data, right? Maybe you can prepare multiple set of data set, right? And then you can just hook it up. And then this is the result, right? So in the Grasshopper component, Jong Hyun, could you click the param here? Params, yeah. So input here, I guess. Okay, I couldn't find it, but there's some record or some panel that you can just save the data. So for example, I inject this one and then get the data, right? And then inject the other data in the time sequences, and then save this data as a sort of number or mesh or whatever. Yeah, so that you guys put this one in a sequence in your panel, or just use a number as opposed to this parameter as a result here. So yeah, I mean, there are many ways, I think.
Great, thank you. I think one of the things we wanted to focus on in this course was how things change over time in urban conditions, and how do we visually represent them to understand, but also to use it as a way to project the future. So I think this is also very useful for myself, but also for the students to, maybe we don't have the exact answer at the moment, but we know that it's possible. But the question is, how do we efficiently might do it? And also based on all what you presented, both of you presented, it helps us to think about not only the technical aspects of it, but how do we set up the right values, hierarchy that generates meaningful information for us to use as designers. I'm aware of the time here, but do we have any last question for the two kind presenters who have joined us this morning? Any final question or comments?
Yeah, for me, in terms of the time series research, it's always very interesting, right? You wanna throughout the history we learn a lot and how the built environment changes, and that we also wanna project for the future development, right? So what I can suggest is that try to collect the data by different kind of historical moment, like maybe from the old map. I don't know like which year, which kind of period do you want to use for the students' research, but like, for example, 60s or 70s or 80s, 90s or 2000, like it will have a very different built environment context, right? So students also build up like maybe 3 different kind of moments of built environment kind of data set, and then do the same network analysis, and can see like which location is more important on this period. But because of some kind of changes between those 2 periods, like maybe the city center kind of function is changed to this location or something like that, based on this historical kind of analysis. And you can also project the future development as well, because I showed you like one of the linear regression analysis. It's just like one-to-one kind of like comparison between the outcome of our network analysis, and actually the dependent variable can be anything. So you can see you will get the mathematical function, with this linear regression analysis, and then you can by using these mathematical kind of math functions, you can also project in the future as well. So yeah, I did actually I'm also doing kind of time series research for Seoul. I have 2 projects now, so yeah, if you are interested in, I can share with you the work in progress later.
Great. Thank you very much for joining us today. As mentioned, they will be open to some questions through email if you have some specific questions. But what I really value of both of the presenters today is that they have these computational skills, but it's not just based on technique and skills, but based and built on top of their architectural and urban design training. So they come from a very specific background that makes their work very unique. So thank you very much for sharing your work today. And hopefully we'll have you back for other occasions and we'll be in touch.